Tesla shared a promotional image on social media confirming that a special Cybercab event will take place on September 3, 2026 in Austin, Texas, where the company is headquartered. Tesla stated, "We're hosting an exclusive event in Austin to celebrate the launch of the Cybercab self-driving taxi service, and you could be there." The company is also running a sweepstakes giving fans a chance to attend and receive exclusive access to the Cybercab. With less than 2 weeks remaining before the event, this is currently the clearest signal that Tesla is preparing for a real-world rollout rather than simply continuing to present the Cybercab as a concept. But what makes this announcement especially significant is not just the September 3rd date. Behind the event, the Cybercab fleet is growing rapidly. In mid-June 2026, around 40 Cybercabs were spotted at an autonomous taxi facility in the Dallas area. Today, that number has risen to nearly 100, more than doubling in roughly 2 months. The facility in Irving, Texas, part of the Dallas-Fort Worth metropolitan area, is reportedly capable of holding up to 212 autonomous vehicles. If Tesla continues moving vehicles there at the current pace, the facility's designed capacity could soon become a real operational limit. This also does not look like an ordinary parking lot. A dedicated Robotaxi hub is designed to support an entire fleet, including charging, maintenance, vehicle dispatch, and remote monitoring. Tesla moving Cybercabs to a dedicated facility in Dallas rather than simply keeping them near Gigafactory Texas in Austin suggests that the company may be preparing for commercial operations in that market. In other words, the vehicles appearing in Dallas could be part of an operating infrastructure rather than simply excess inventory coming out of production. The production timeline is moving in the same direction. Tesla began producing Cybercab at Gigafactory Texas in April 2026. By July, a passenger service for employees had been launched, while multiple groups of Cybercabs continued appearing in suburban areas around Austin. More than 100 vehicles have recently been recorded in Dallas, along with smaller fleets spotted in other parts of the United States. Tesla fans have also continued sharing images of parking lots packed with Cybercabs, further fueling speculation that a major launch is approaching. The information previously reported that Tesla employees had been informed of plans to begin deploying Cybercab through an employee service on public roads before integrating the vehicles into Tesla's Robotaxi network in Austin. That makes the September 3rd event potentially more important than a conventional product presentation. If everything proceeds as planned, Tesla could announce the transition from testing to an actual autonomous ride-hailing service in Austin. Musk previously said Tesla was planning to begin producing self-driving cars before 2027 and aimed to sell them to individual customers for less than $30,000. The Cybercab is designed quite differently from the Model Ys currently being used in Tesla's Robotaxi fleet. Mass-produced Cybercabs are reportedly using more powerful FSD computers with more memory than vehicles currently running AI-4 hardware. Tesla has not clearly confirmed whether this configuration is AI-5 or AI-4+, but it is clear that the Cybercab is being prepared for greater computing demands. One factor that could determine how quickly the Cybercab expands is FSD version 15. Musk has said that Tesla does not want to significantly accelerate the expansion of its autonomous vehicle network until it reaches this generation of FSD. This is important because, with a personal vehicle, FSD only needs to handle one user's journey under a range of conditions. A robotaxi has completely different requirements. The Cybercab must be able to operate thousands of trips without a driver, continuously deal with unexpected situations, and maintain a high enough level of reliability for Tesla to operate an entire fleet remotely. FSD version 15 is expected to have roughly 10 times as many parameters as current FSD versions. If that figure becomes reality, this would not simply be another routine software update. A larger model could allow the system to process more factors simultaneously, from identifying vehicles, pedestrians, signs, and lane markings to predicting the behavior of surrounding objects. More importantly, the system needs to turn all of that information into driving decisions in real time. For the Cybercab, this capability is especially important because a single mistake would not simply affect one vehicle owner. It could directly affect a passenger using the service. That is why the Cybercab's computing hardware has become such a major part of the story. Mass-produced Cybercabs are reportedly using more powerful FSD computers with more memory than the Teslas currently running AI-4 hardware. Tesla has not confirmed whether this configuration is AI-5 or an upgraded AI-4 variant. But increasing computing resources could provide a major advantage if FSD v15 actually requires greater processing capability. A larger AI model needs more memory to store data and more computing power to process tasks in real time. This suggests that Tesla may be building the Cybercab not just for the current version of FSD, but also for the autonomous driving software generations that come after it. This also explains why the Cybercab is not simply a Tesla with the steering wheel removed and placed into a robotaxi service. From the beginning, the vehicle was developed around a different mission: continuous operation, autonomy, and operation without a driver. A consumer Model Y can be parked in a garage, have its cameras cleaned by its owner, and be charged overnight. A Cybercab could potentially run dozens of trips every day, pick up and drop off different passengers, and operate in rain, dust, at night, and under many other road conditions. As a result, the reliability of every sensor in the computing system becomes far more important. One of the clearest examples is the camera washing system integrated into the Cybercab. All exterior cameras are equipped with their own cleaning system, a detail that may seem minor but is extremely important for an autonomous vehicle. The cameras are the direct source of visual data that Tesla's system uses to observe the surrounding environment. If a lens becomes covered with dust, water, mud, or other contaminants, the quality of the incoming data can decline significantly. With a human-driven vehicle, the driver can notice that a camera or viewing area is obstructed and take action. But with a driverless robotaxi, the vehicle must maintain its own ability to see. This creates a major difference in design philosophy. Tesla does not simply need the Cybercab to see the road when it leaves the factory. The company needs the sensor system to continue operating reliably after thousands of trips. A robotaxi could run from morning until night, then recharge and return to the road. If even one camera becomes dirty and can no longer provide reliable data, the vehicle's ability to operate autonomously could be affected. That is why the camera washing system can be viewed as part of the vehicle's operating architecture rather than simply an additional convenience feature. The Cybercab also comes with an integrated Starlink antenna, adding another layer of connectivity to the vehicle. A robotaxi does not only need to drive itself, it also needs to communicate with fleet management systems, receive information, transmit data, and maintain the ability to be monitored remotely. Tesla may need to know where the vehicle is, how much battery it has, whether there is a problem with a sensor, and whether the vehicle requires assistance or maintenance. Reliable connectivity becomes especially important as the fleet grows from dozens to thousands or even hundreds of thousands of vehicles. This is also where the Cybercab could be fundamentally different from a conventional Tesla. Tesla is not simply trying to build another car, it is trying to build an entire system consisting of the vehicle, FSD software, AI computers, connectivity, fleet management centers, and robotaxi infrastructure. As the number of vehicles grows, each Cybercab becomes a node in that network. The vehicle receives a trip request, drives to the pickup location, transports the passenger, completes the trip, recharges, and then receives its next assignment. All of these processes need to work together. And this is exactly why more powerful hardware could provide much more value than simply increasing processing speed. If the Cybercab has enough capability to run larger FSD models in the future, Tesla could improve its autonomous driving performance through software without replacing the entire vehicle. This is a major advantage for a robotaxi fleet. A personal vehicle can receive several upgrades during its lifetime, but a commercial fleet needs to remain operational and generate revenue continuously. The more Tesla can upgrade the Cybercab's capabilities through software, the less the company may need to replace its hardware. However, one major question remains. Is the Cybercab's current hardware actually powerful enough for FSD V15? Tesla has not publicly disclosed the complete specifications of the computer inside mass-produced Cybercabs, so it is impossible to confirm whether the vehicle is using AI-5 or an upgraded AI-4 configuration. But if Tesla genuinely wants to deploy robotaxis at scale, preparing the hardware in advance for future generations of FSD would make far more sense than launching a limited platform and then having to change it later. In the long term, the Cybercab could become the first platform to demonstrate how Tesla wants to transform FSD from a feature inside a car into a complete autonomous vehicle operating system. FSD V15 would be the brain. More powerful computing hardware would provide the processing capability. Cameras and camera washing systems would provide the data. Starlink and other connectivity systems would maintain communication, while robotaxi hubs would handle charging, maintenance, and fleet management. When all of these components work together, Tesla would have the foundation to turn the Cybercab from a driverless vehicle into a commercial vehicle capable of operating every day. So what is most important about the Cybercab is not simply its shape or the fact that it lacks traditional driving controls. The bigger story is how Tesla is designing the entire vehicle around autonomy. If FSD V15 reaches the level of capability Tesla expects and the Cybercab's hardware is powerful enough to run those models, the vehicle could become more than Tesla's first robotaxi. It could become the foundation for a fleet that can be continuously upgraded through software for years after leaving the factory. That is why September 3rd could become an important milestone. Tesla has been producing Cybercab since April, launched an employee service in July, moved nearly 100 vehicles to a Dallas facility designed for 212 vehicles, and continued sending vehicles to other locations. If these signals accurately reflect Tesla's plans, the Austin event could mark the moment when Cybercab begins transitioning from an ambitious project into a real-world robotaxi service. What powertrain and charging details can we expect? Some of the most important Cybercab specifications surfaced earlier this year through a U.S. Environmental Protection Agency filing. The document reportedly provides clues about the battery, efficiency, range, and powertrain of Tesla's purpose-built robotaxi, giving us a much clearer picture of what could be hidden underneath its futuristic design. According to the filing, Cybercab could use a 53.3 kilowatt-hour battery pack and achieve an EPA-rated range of up to 418 miles. That figure is particularly impressive for such a relatively small battery, suggesting extremely high efficiency. Tesla has previously indicated that Cybercab could achieve at least 5.5 miles per kilowatt-hour, significantly higher than the roughly 3 to 4 miles per kilowatt-hour achieved by many current EVs in real-world testing. The powertrain is also unusual for Tesla. Cybercab is reportedly equipped with a 219-horsepower electric motor driving the front wheels, marking a major departure from Tesla's traditional rear-wheel drive and dual-motor configurations. A front-mounted motor could help Tesla maximize interior space while keeping the vehicle compact enough to accommodate passengers comfortably. Weight is another important advantage. Cybercab is reportedly rated at just 3,113 pounds, or around 1,412 kilograms. That is remarkably light for an EV of this size and could help explain its high efficiency. Tesla has not yet revealed official acceleration or top speed figures, but those numbers may be less important for a vehicle designed primarily for urban transportation. The most interesting technology, however, could be the charging system. Cybercab is widely expected to feature wireless inductive charging, potentially eliminating the traditional charging port altogether. Instead of waiting at a supercharger, the autonomous vehicle could drive itself onto a charging pad and recharge automatically. That would be especially useful for a robotaxi fleet. Cybercab could finish a passenger trip, return to a charging station, position itself automatically, recharge, and immediately return to service without human intervention.